You're official today, Rusty.
I know it. I'm at the bottom of my laundry basket. Dr.
Yes.
Bri, such a delight to see you today.
But I have two thumbs.
Two thumbs up. No power washers today.
No. We should be good. I should be able to stay in this location.
Oh, that's awesome. That was actually lovely to have a nice tour of your house. It looks really cool.
Kind of ridiculous, but it worked.
It did work. It did work. Well, people
Well,
are still signing on. We'll give them another couple seconds here. Cassie, go ahead.
I was just going to say, people are just starting to come on, so that's a good thing. Let's just wait a few moments.
Sure, sure. Cassie, if you want to put the Padlet in the chat, after Bri's talk, I'm going to give them a break so they can put their abstracts in the Padlet. Good morning, kind faces. Good morning, Riava and Saraman. It's nice to see you guys. Hey there, Manuel. I have to say, it's a very gray day here in sunny Colorado. I think this in the 18 years I've been here, this has been the grayest and the rainiest summer we've ever had. And I can't say I don't mind. I really kind of like it. But the grass now is way above my armpits, which we're going to have to pay someone to hack it down because of, the potential for wildfires later in the season. So good. So Cassie's putting a Padlet in the chat. And what we're going to do with your abstracts is the same thing that we did last week with your talks. So you'll get a break after Bri's talk so that you can take your abstract and put it in the Padlet. And then we'll use that as a way to organize us and move forward. So nice to see the faces of Nikhil and Trisha. Thank you for being here today. Well, I think we're
Still rapidly coming on. Hold on.
they're still rapidly coming on. So how was your 4th of July, Dr. Bri?
Oh, it was really good. I actually I live in South Dakota, and I made a quick run over to Wisconsin to get just a quick 6-hour drive to Wisconsin to get a bunch of fruit trees, and then I planted them all.
Oh my gosh.
The holiday weekend. So I'm gonna have fruit maybe next year. Actually, this year, because some of the trees already have apples on them.
So. Oh, that's so awesome. We have one fruit tree between my neighbors and myself, and it's really awful because the bears just go nuts. Bears actually come and visit us for the apples, and it's super, it's super disgusting. So, well, they're adorable, of course, but it's dangerous. So we stopped the idea of the fruit trees, but we do have Saskatoon berries because they actually come up and they ripen sort of at a time when bears really aren't looking.
Oh, so, that's good.
Yeah, so we get to eat like 2 or 3 and the birds get the rest. So
yeah, wow. I mean, I guess I have it easy. I'm not really contending with bears or deer or anything like that in town where I live.
Yeah. No, we're really good, and we have lots of deer as well. But towards the south part of our road, there are people that feed the deer, and so they don't actually come up here and bother my garden at all. So it's a plus.
Okay. Yeah, I guess it is.
But also, speaking of gardens and flowering trees, I always have a nice big garden, and this year nothing is doing well because of all the rain, actually.
Oh, really?
Yeah, like I planted tomato plants a month ago and they're still the same size. They're looking a little brown. So I actually have put fertilizer on them because a friend of mine said that maybe because of all the rain, all the nutrients have leached out. And that does make sense. So
I wonder if like they're just not getting enough light because of the clouds.
it could be. It could be.
So
It's
hopefully
amazing.
the fertilizer works, but if it doesn't, yeah, it's kind of weird.
It is kind of weird. Not a good investment on tomatoes, peppers, and eggplants this year. Got lots of radishes though. Radishes are coming up like crazy. So
Well, they're really quick.
radishes and bok choy. I'm awash in radishes, bok choy, and lettuce. So I guess that's good. So
Yeah, it sounds like your cool weather stuff is doing really well.
my cool weather stuff is doing excellent, and spinach. Okay,
Yeah.
I think we got a quorum here. Do we, Cassie?
It looks like everybody's rolled in.
Okay, well, it's 9:05, and I want to honor our time with Dr. Bri. I think all of you know her better than you know anyone because she was able to give us a little bit of a story about how she got to where she is today. And it's actually excellent you're talking this week because this week people are beginning their projects and they're going to also be looking to access and download satellite data. So this is actually really a perfect timing. And so I think we're ready to go if you'd like to share your screen.
Okay, great. Did you still want to go over that figure from before, like, or
Yeah,
no?
that's a great place to, thank you. That's a great place to start because Bri has a figure that she used for her research with termites, which just shows you how the earth is a system and everything interacts with everything else. Everything is connected. Everything else is something that Leonardo da Vinci said. So it's not a new idea, but it's kind of a new idea for earth science. It was earth system science started just about 25 years ago, where we begin to look at the connections between the atmosphere, hydrosphere, lithosphere, and biosphere. And I thought this diagram was super excellent because when you are thinking about your questions in your AOI, this is why when we try to understand whatever it is, whether it's my tomato plant's dying, whether or not there's an outbreak of mosquitoes or wildfires, we have to look at the whole system. So this, I think, is a great introduction to why we need all different kinds of satellite data, Bri. So take it from here, but I do love your diagram, by the way.
Oh, thanks. It's like we said last week, it was not made overnight and it was made over several years and multiple iterations. But I just figured, like, not everyone is familiar with termite mounds or my research. So on the left, I have this kind of cheat sheet of how to read the figure because when I just re-looked at it, I realized it's not super intuitive if you haven't seen a lot of these. The whole concept of this thing is really at the bottom. And so the whole point of this figure is explaining or trying to understand whether there'll be plants on a termite mound or not. So the left side has bare termite mounds, so there's no plants. But the vegetation next to the mound is greener or enhanced. And then the right side has mounds that are grassy and have plants on them. So kind of starting from the bottom, we're just looking at the probability of either one of those happening kind of along a continuum. And then we also know how these mounds function in the environment. Like the bare mounds have a concreted surface, kind of. It's very hard. It disperses water, and that water takes with it soil and nutrients within the soil, and that moves laterally. And then has the potential to enhance the neighboring vegetation next to the mound. On the other hand, the grassy mounds let the water seep into it really well. And so those mounds already have the nutrients and they get additional water. And so that's where the plant growth is enhanced. And so then you kind of work backwards. You can work backwards, or you could start from the top down. That's kind of up to you. For me, I like to just say that the reason it's a top down situation is because it was supposed to be envisioning like the scale of things. So at the top is like the largest scale, like across regions. And then we shrink down to like the landscape scale, which is smaller than a region, but not an individual mound. Then finally we get to an individual mound. And then on the edges, we're looking at different factors that have the potential to influence the probability of plant growth through different mechanisms. And those mechanisms are highlighted in different colors. So the mechanisms that the purest mechanisms are water, nutrients, and soil compaction. But then there's actually like physical properties of, or like phenomenon that are happening on the landscape or at different scales that can affect these things. So at a really large scale, we're thinking about like what types of plants are there, how do they reproduce, how much rain happens, how long does the rain happen for, and how heavy or hard is it, like. And so that in both directions influences water, which has the possibility to either reduce or enhance plant growth. And that in return has a possibility to affect the plant colonization rate on top of the mound. So how able any given plant is able to start growing on the mound. You know, and so it's just kind of thinking about all these different things that happen at different scales and happen with different types of plants or animals or soil, but kind of combining them into a major concept in this figure. At the landscape scale, like, so not at a country or, you know, seasonal level, but like at a smaller space, like maybe the size of a national park or something like that. We're thinking about the different slopes, like nutrients that are actually in the soil, and what types of animal disturbance could be affecting the distribution of nutrients. So what happens when animals are around? They go to the bathroom. And so what does that mean? There's extra nutrients. So if there's more animal disturbance, there's more animals around, you're going to get more nutrients, and that could make it easier for plants to colonize, because the place where I work, which is a savanna, is broadly a nutrient and water limited system. It's more water limited than it is nutrient limited, but the extra nutrients help plants do better. So kind of just like thinking through different like kind of thought experiments about what happens when you adjust certain parameters and include different ideas. And then at the individual level, we have like the actual termite mounds. If the termite mound is really steep and it's like a really steep triangle, it's actually harder for plants to even get their seeds up and stay on the mound itself. They'll just roll to the bottom, or like they won't have a way to get stuck in. But if the mound is more like casually sloped, then the seeds could easily just stay there. And this is not, what would you say, comprehensive, but it's a really decent start about thinking about some of these factors and kind of putting them together in a way where you can use hypothesis testing to kind of systematically learn more and like refine the model. Yeah, so that was a lot. Does anyone have any questions on that? before I move ahead?
Yes. I don't have a question, and I know that Peter is chomping at the bit to have his 2 cents about this. But if you want to put that back up there, we can ask the students to do a screenshot so they have this. It's also in the in week 5 if you're interested in looking and finding this. But it's what's really exciting about this is that this is exactly what we're trying to do with the mosquito experiments. Think about your traps at the bottom, the probability of mosquitoes found in these traps, you
Oh,
know,
cool.
with respect to the region. Do you live in a desert? So the chances are highly unlikely anyway. Landscape, are you near the vegetation that the parent mosquitoes require in order to live so that they're going to be there? Do you have enough water to fill the traps? Let's talk about, let's use the same model and talk about our AOI, the probability of whatever you're thinking about examining in your study. There's your AOIs right there, but those are their areas of interest where they have land cover data, Bri. And,
Okay.
there's the region that you're in where there are already factors that are determining, what kind of vegetation you have there or whether or not it's a completely urbanized landscape, and then
Yeah.
here are all these other different variables that you can examine as a predictive model to explain something that you have here. Peter,
And
you're
some of the, oh, sorry, go
I was
ahead.
just going to say, if Peter's online, he might want to say just a couple things before we go on. But this is really the way in which when we think about the Earth system, we're thinking about how all these different factors come together. And if you're doing a climate model, for instance, what Bri would have done is she would have attributed numbers to each one of these parameters. And then each of one of these parameters corresponds to a data layer. And then that would be used to try and predict whether or not you have the chance of a wildfire here or a disease outbreak, or whether or not you have a grassy termite mound. So I just thought this was completely brilliant. And, you can begin to see how thinking using a systems model approach is going to answer a lot of questions that we have about the world around us. So this is why I thought this was so completely brilliant, Bri, and I just love it so much. And I hope you are able to reproduce this in color wherever you published it.
Oh, well, it's coming out soon. I also would like, I think it will be able to be in color. Yeah.
Okay. Oh, great. Well, thank you so much for that. And I think that already you've earned all the money that you're making giving this talk today. So, Bri, like so many, like all of our speakers, are volunteering their time because they're investing in your future. So, thank you for that. And we're ready to hear your talk about AppEEARS, my friend.
Okay, great. Yeah, and I'm absolutely happy to volunteer my time because I've had a lot of people volunteer their time to me, and it's I feel like it's paid off, and I'm happy that they did that. So okay, let's talk about AppEEARS somehow. Okay. Just before we get super into AppEEARS, I wanted to show you guys this figure. I did not make it. I did make this. This is actually a sticker, data access made simple for AppEEARS. But in the foreground, this is something that a group called OpenScapes put together. And the way that they think about doing science is very collaborative and awesome. And I just wanted to make sure you guys just took a peek at this real quick. In the lower left, I know they're a little cut out, but these are sad animals in a cloudy spot working alone. And these on the right-hand side are like happy animals being at the trailhead together. And that's kind of like, I think this space is where things are going, and it's really exciting. And this is just to say, anytime you guys are working on stuff and, there's no reason to stay in this space for too long. You can certainly learn independently and get very far on your own, but it's nice to talk to other people who are also learning similar things that might have different skills that could help you, and then you could help them later on. And so hopefully this is AppEEARS kind of helps you guys along, and If you ever have any questions, you can reach out to me directly, or you can contact, put in a comment through the website. But the point of this is to just say that science is really fun when it's collaborative, and it's good to ask questions and work as a group and kind of learn together. And that's something I'm learning more and more as I continue in my career. Okay, so AppEEARS is supposed to make data access simple. It's used to extract and explore geospatial data. And so basically what it does is help you extract either point or polygon data, a point or shape, point files or polygons from any area, like your area of interest, through space and time, and like by different bands. So this is just like a researcher that I had in a presentation previously, and she was looking at winter. She was actually looking at winter conditions in Chicago through the years with different types of data. So there's the snow water equivalent, there's population density, there's temperature, there's land cover, and there's also snow cover. She's able to get that data in one request from AppEEARS and over multiple years. So it really, and the thing that is also maybe not apparent from here is that unfortunately, things are not as always easy as they should be. And so on their own, these data naturally live in different repositories, different places. You have to go to like 5 different places to get these different data sets. But AppEEARS helps you go to lets you go to one place and get all of them together, which is a big time saver. In general, like there's all kinds of different data sets that are available within AppEEARS. So you have your normal spectral reflectance, you have precipitation, there's all kinds of vegetation and phenology indices. And so you can just see that this is kind of an extensive list. Depending on what kind of research you're doing and what scale you're working at, there generally should be something, if you're doing geospatial analysis, there should be something of use to you in AppEEARS. And if there isn't, I want to know about it. And I'd like to know what you would like to see in there. Okay, so this is what AppEEARS looks like once you get inside. And I think I'm just going to cruise over this. Well, let me just point out a few things. Let's see. This is the name of our sample at the top here. Then you have the date range you're looking for. Once you select an actual product, it lets you add bands from that product. And bands, I mean, I guess I'm not really sure what your guys' background is, but inside a geospatial, inside like a remote sensing product, there's usually different layers, which either like that can represent different like bands or wavelength values, or they can also represent different types of like synthesized data associated with that product. And then you can also see like where your sample is. You can also explore the requests after you place them. And as a user, you'll have like, this will stay with you. Like as you put in requests, like you'll always be able to see what requests you previously made, which is really cool. Yeah, so basically you have a single data access point for a good number of products. Some of the information that can make it complicated to understand how to access this data is obscured. And all you have to do is know the location you want data and the product that you want, and you'll be able to subset it within the time frame you need and kind of download only the data you need instead of like a lot of really large files, which will make your computer slow down. I guess what I wanted to do was just kind of go into a live demo and see if you guys wanted to follow along with your area of interest, or I guess it's kind of up to you guys. I think it will be better for us to go through it together rather than just to have me talk about it. So I wanted to keep this portion of it kind of quick.
I think that's actually an excellent suggestion, Bri, and I know that a lot of people love to do that. So if you have your center point lat long for your area of interest, get that handy, and we'll start up with that in just a minute.
Okay, sweet.
While we're waiting, does anybody else have any other questions about AppEEARS? AppEEARS is a fairly new product, correct? When did it open up?
It's kind of before my time. I guess I want to say it's 10 years old, but that might be too old.
I think that's too old, but it's the thing that's really exciting about AppEEARS is that like Bri said before, you'd have to download a whole lot of data and then subsample it, and this way all that work is done for you through this system. So it's really quite remarkable, and it's really a piece of data democratization, isn't it, Bri?
I'd say so.
Yeah.
It's a really good start to that, and it makes it pretty easy to access the data. You still need to pull it into somewhere you want to work with it, but it really does make it really saves quite a bit of time for data access, I'd say. And also exploration, turns out, is really useful for like kind of looking at the data before you download it too, like after you make the request. And I'll kind of show you guys that. Do you guys have an Earth Data login?
We have not asked them to do that. I think you mentioned it last time.
Okay.
Actually, I did mention that like 3 weeks ago for everybody to get that one, their Google Earth Engine account, and I think there was about 6 of them. So hopefully everybody already has this one done, but if not, it's a really fast registration.
It's super fast. So I guess what I'll do is I'll put this in the chat. And if you guys don't have one, go ahead and sign up for one now. And so basically this is just something to get access to NASA resources. I don't think pretty much everyone has to just have one. And even to log into AppEEARS, you need to have one. So I'll also put this link in the chat.
And I'll mention too that login will get you into a lot of other data sorts and places as well. So it's kind of a universal access to NASA data piece of things. So, it goes beyond just this one. So you'll be able to use it quite often.
Yeah. Like Earth data search, like if you were, this is a kind of popular location to get data and kind of explore what's available. If you want to download data from here, you need this Earth Data login. So that's exactly right. It's not. And
Bri, isn't that the same thing where if you want to access this programmatically, like through the API, you also still need that login?
Yes, you still need to authenticate your login information.
Okay. Yeah. Any of you programmers out there thinking about that's one thing to recognize is here we're kind of showing like the way to start to understand the system, but there's an API on the back end that allows you to programmatically get at a lot of these things. So just kind of recognize that stepping process at first, just what the heck is in here? Then you can start thinking about how to access it more rapidly.
Yeah, and AppEEARS actually also has an API. So if that's something you guys are interested in, that's awesome. I don't really have that today, but
no, I just kind of wanted to mention that to people because 3 years ago we had a group who actually used the API to access a lot of the data and to do some comparisons between our ground photos and satellite imagery. So they were able to hook in with the API to be able to access this. So it's been a really good tool for us in a lot of different ways, from just the exploration that we'll be doing here to actually implementing something a little bit more sophisticated.
That's awesome. That's great. Okay, did anyone have any? Well, I'll just go ahead. If you do have a question, like just someone either speak up or let me know, and we can address it then. So if you guys don't have a login, you'll come to this page and you'll be asked to sign in. You'll need your Earth Data login. So that's how that's going to work. If you already do have a login and you just previously logged in, if you go to the AppEEARS page, it should recognize you. And this is my name, Bri Lind. And so then this is what you'll see first. And oh gosh, I might have to shut the door. I'm watching a friend's dog today, so no power washer, but just not my dog barking. Frankie, that's not gonna work. It's definitely not gonna work. Come on. Watch out. No barking. Okay, so hopefully that gave you guys a couple of extra seconds to kind of get your login information. And so as you can see at the bottom, there's data sets from these different places and then also NASA. So that's great. The first thing that people normally want to do is kind of extract data. So you can go to the upper left and either extract an area or a point sample. So what I'm going to do is, I think I'm going to do an area. And so then it gives you an option that you can start a completely new request. You can copy an old request, or you can upload a file. I rarely use this. Usually if I have a request, I kind of just put it in a new request. So let's go ahead and do that. Yeah, I live in Brookings in South Dakota. So I'm going to name, and I'm going to pull out some vegetation and land cover data. So that's what I'm going to name my sample. This is what I'll see when I go to explore the data later, that it's called Brookings, South Dakota Veg.
And I just want to thank you, Bri. And it's so nice. And you don't mind if I interrupt, right? But
no, go for it.
Yeah, I just was going to say, this is a very well thought out identity for her sample. And so, think about that as opposed to like sample one or whatever, because then you can always go back to it later.
Yeah. And yeah, as much as you think, you do have a good memory, and it's true. I also have a good memory, but it doesn't mean that we're going to remember what was in sample 1 or trial 3 or whatever. So try to be descriptive. And then you can do a couple of things here. You could navigate physically with your mouse to the location that you're interested in and kind of draw a box around it. That's kind of what I like to do. This is Sioux Falls. That's kind of a big city. I'm an hour north of that over here in Brookings. So I'm just going to go ahead and draw a rectangle around it. If I had a polygon or a shapefile that already had my whole town put together, I mean, like the area of interest that I, knew I wanted, I could add the file here. Sometimes the shape files can be a little finicky. So the GeoJSONs tend to work better. I'm not sure why that is.
They're simpler, Bri. That's the main reason. It doesn't require 4 or 5 different files. And the nice thing is, Bri, right here, they've already created, they have a polygon for their 3-kilometer area, as well as 37 100-meter polygons that they'll be using. And so they will actually be uploading those. And the nice thing is, here they should be able to click the open button and open the GeoJSON that they actually downloaded as well.
Okay.
So I love that you're showing that website, because that was was where I was gonna go next. So show it. What is this website that you're showing us here?
Yeah, so just in case, for whatever reason, like sometimes your shapefile doesn't work and it's hard to explain why for people that aren't expert programmers or whatever, you can do the same thing here and kind of zoom into your area of interest, make a GeoJSON. Let's see if I can get this set. There we go. So now I know where Sioux Falls is and Brookings is again. I can just go ahead, draw that same polygon, I think. Yep, there we go. And so this gives you the whole GeoJSON file. You don't actually even have to know how they work. I mean, it's kind of intuitive, like it's just telling you the coordinates of the corners of your area of interest. But anyway, you can copy this, you can save it, and then you can export it and you can download, add that into AppEEARS. And that usually works every time. For some reason, I seem to have bad luck with my shape files on here. Anyway, so there's a lot of different options for selecting your area of interest. And so then the next thing you're going to do is select your date. If you know that you want a multi-year thing, you can just go ahead and click, is this date reoccurring? And then you say the year range that you're interested in. This requires a little bit of upfront information about what kind of data products you're interested in using and if they're available in the given time frame. I'm working with the AppEEARS team, and they have a lot of stuff to do there. It's actually really a lot of work to maintain software like this, but we're gonna work on getting this number down to the current year, because there is no data available in 2050. So we have to bring that slider down. 2022 or 2023 is fine. And so then you don't have to worry that this isn't showing that date. It's just going to do the months now. So I guess what I'll do, I like to kind of do the whole year sometimes to get an idea for things. Because I know that I'd like to look at the vegetation data and see how it changes over a couple of years. I'd like this sample to process really fast. So maybe I'll make it a little bit shorter in terms of this temporal time frame. But I'll just do it from January 1st to, well, let's see. What year did I pick? 2022? I'll do to December 31st from 2020 to 2022. And then I told you guys I wanted to do some vegetation products. So I'll just type in, but I'm not exactly sure what I want. So you could do something like plant. Oh, no, you can't. You could do phenology, I think, and see what kind of products are available. So it looks like we have a AppEEARS product. You can also start typing something like NDVI, and then it will show you all of the different indices that are available. And it also gives you details. So like this is from AppEEARS. It lets you know that it's a 1,000-meter product, which is pretty big, and it happens on a monthly basis. So, well, I don't think I really want that. I think I prefer, sometimes I really like the combined products. So I think what I'll do is take a combined land cover type, and then I get to select what other types of bands I want inside this product. So if you don't know what LC Prop 1 is, it tells you by clicking the info button. It's the land cover classification system. It's a specific type of system. And there's 3 different systems as far as I can remember. And then there's different land cover types available. If you want to know more about this combined land cover MODIS type product, the easiest thing to do is copy the full name here. We'll go to the LPDAC website actually and go to data, search data catalog, and go to the combined MODIS. Let's see what comes up with that. Whoops, not enough. Sometimes it's better to do the whole thing. MODIS land cover type. Okay, so seems like we could work on our filtering algorithm quite a bit. Oh, well, I guess it would be better to use this top bar here, but I guess we're learning together. Which, let's see, 500-meter product. You can also usually type the name into Google and it works really well and goes to the LPDAC website.
And there's also that, you notice the version number and everything underneath there too. So you hit it, Bri. But yeah, like the naming conventions, I'll just mention everybody can learn quite a bit in terms of how NASA labels their files.
Yeah.
And, when you're just learning and starting out, look at those. Pay attention to how they are put together, because there's a reason that they've done that. And that actually has been learned over many, many years. And so one of the challenges I'd say is just like, what is a good naming convention? And then, figuring out how other people have done that and implemented that. And it may not make sense, but there is a lot of data and information in those file names.
Yeah, so if I was being smarter, which I'm going to start being smarter now, one of the fastest ways to get to a product, if we weren't really sure what we wanted, then we landed on this and we know we want it. The fastest thing to do is to go to Google. I think it's the fastest. Oh, so that's neat. Now my google.com. Okay, and then you type in this product name here. So and I always do LPDAC in front of it because we actually have some pretty decent information on the product. So LPDAC MCD12 Q1, and then this is version 6. And so this is something else other people search. You can tell because it's like already auto-filling for me. There is no version 6.2 yet. 6.1 does exist and it's in AppEEARS, but right now we're looking at version 6. So this comes up right away. Easy peasy, much faster. And so now we can go here and kind of learn more about what this product is. It gives you a description. It tells you it's combining data from 2 sensors, Terra and Aqua. And then you can kind of go through and get other information as well. It will tell you what's changed from previous versions. You can see what layers are available, and that it gives you all the characteristics. So this is actually really handy to kind of go in and see, okay, this is a land cover type associated with the International Geosphere Biosphere people, like this IGBP classification. Then type 2 is a UMD classification. Type 3 is not really, it's land cover type based on LAI. And so based on our needs, I think I'm just going to go with the IGBP type 1. But this is kind of a way for you to tell all kinds of information about the data that is not, that just to get more information in case you're unsure. And don't feel like you need to memorize all of this stuff. What is best is to know where to find the information. It's impossible to know every data product and every sensor, but after a while, you'll kind of get a hang of what's available and what it offers. So we'll add that in, and then I'll add in the quality layer just so we can interpret how good this land cover data is. And then, oops, I'll just make this bigger. The next thing we'll do is get rid of this, since we already have the sets we want. I mean, the layers we want. And then I think I'll do a combined land cover dynamics as well. So that's the Q2 product. And so this has EVI, which is very similar to NDVI, the normalized vegetation index. So this will kind of give us an idea of green up and how high the greenness gets in an individual area. Yeah, so you can pick whatever layers you want. And so I'm pretty happy with that. And now it's time for me to decide what kind of file format I'd like. I prefer to work at GeoTIFF, so I'm going to do that. And then in terms of projection, I usually just go with native, but there's all different kinds of options that you might choose to use based on your, like, how you're working with the data. Geographic is also a really good one because this is a small area, so it's automatically going to put it in the right geographic projection. If you're working over a larger area, you might not want to use that because it would go over multiple projection zones, and it would be complicated. Then all you do is press submit, and that's that. We have some just a few warnings up here that generally don't affect people that, and it's good to read. But the main thing you'll notice is, that this sample was completed. This request was completed, and you might have heard that beep that was saying, oh, you just got an email saying that your AppEEARS has been, this particular request has been submitted. And then helpfully, if you're just like getting back to it later in the day or something, you can go ahead and like click that link and it will bring you right to your request. Uh-oh. I don't think it's made it yet, but usually that doesn't happen. Oh, and another thing to note, actually, since we are having our meeting right now, is that AppEEARS and the land processes DAC has to go through a maintenance times every single week. And so actually Wednesday mornings are generally a horrible time to try to have things work perfectly because of the software maintenance. So if you do encounter an issue and it is a Wednesday, I would try again later. But yeah, so let's look at these other tabs up here. There's the Explore menu. And so here we can see that this sample I just put in has already been queued. And that doesn't mean it's being processed yet. It just means that it's in line. Previously, sometimes I come up with silly names. You can see I'm not always as thoughtful as I should be. B-Town, Brookings Town. I did a point sample request here. And you can kind of click and view your previous requests and see what happened in them. One of the ways to explore the data is you can change what the layers are. So I had pulled in an LAI, which is kind of similar to greenness, leaf area index from MODIS. And whoops. You can compare that with the LAI. Whoops. Oh, you know what? Let me look at the details, sorry, of this request. Oh. Okay, so here's what's happening here. This request is still available to look at, but it's not processed anymore. So the data that went with it, isn't available. Let's see. Thank you. Oh, it's been processed already. That's useful. Okay, so let's go back and see this request. Oh man.
Bri, that's actually a great example because that's similar to what they're going to experience, you know, and part of what I think you can highlight here is the spatial resolution.
Yeah.
And, you know, and that's part of the reason why we have specifically set up this sort of multi-sample approach so that we're, you know, can work at that 3 kilometer pixel scale with 1 pixel. But part of this is just like, you know, you at the very beginning here, you listed out lots of variables. And so one of the things that you're doing here is just, you know, would be one of those variables that you would bring in, right? Like it's one value, it describes, you know, the land cover at this location, right? It's only one data point. You know, you still need a lot more information to do anything with this, but it's at least, you know, you would expect that with this type of data. You know, for that area, you would only expect to get 1, maybe up to 3 pixels, right? Because of sort of that size. And so to me, that's one of those things that can be easily missed when you're reading all those details is what is that pixel size that you're getting and how many would you expect? What is sort of your expectation coming out of this too, based on what you know about the values going in? Right. And that's what I really appreciate about AppEARS is this quick ability to see, okay, here are the values that I'm getting. The visualization is horrible. But you know, because the colors make no sense. That.
But you can see it does make no sense, but it does say category dense herbaceous. So you do know what it is and you know how many times it happened.
Exactly. That to me is the point, is like you said, it's the exploration piece that once you're kind of happy with, oh, okay, here are the values that I'm getting, then you can move on to the next piece of getting the data or working with the data or kind of making it pretty.
Yeah, exactly. And so I did start with an area sample, and sometimes the point samples are actually a little bit more give you a little bit more information in terms of exploration. So let's just quickly run this. I'm going to click this little button down here to say where I want the points. And we'll do Brookings and the surrounding area. If I had time, which I don't, I could actually label these. Okay, I'll do it really quick.
And this is something that they could do too. You know, everybody, you already have your ID number that we did before, right? Going from 0 to 36. And then we already have a list of the latitude longitudes. So that could be something that you could easily just put right into here and be able to, you know, calculate along. But I really like this ability to just type in the coordinates, right? So if you have coordinates, you don't have to do anything special. You can just copy those and place them in.
That's right. And then you can put this in, choose your time frame. I think I'm just going to do the phenology this time. So we'll be able to look at something kind of more fun. And then whatever it is, you can choose, well, yeah, okay. Wait, I'll just make this that just in case. Okay, so phenology. But look, so I said I wanted phenology, but my year range is 2006 to 2012. This product is from 2013 to 2020. So this isn't a good fit for me. And like you can already tell because that information is right there for you. So if you know where to look, you can actually see quite a few things. This data set, on the other hand, is 2000 to now. So that would cover my interest. So let's just try that. We'll put in EVI and NDVI. And what did I call this? Nothing. I need to name it something. Brookings points edge. Okay, and then we can submit that. And then I'll again get an email saying that it was put in. I think this one will process kind of quickly. And then in the meantime, I can see if you guys have any questions. Last week, you were really great with questions, and it was a lot of fun. While you guys are thinking about questions, if you have any, there's this help section here where you can kind of see the documentation about like kind of tutorials and kind of working through things to get exactly what you want in this help section. There's an API that you can leverage if you'd like to kind of programmatically put in requests and get what you want from them. There's also a change log. So sometimes things, we just implemented this, sometimes things change and it makes AppEARS not work as you had experienced it working previously, especially on the API end. So now there's a change log where you can see what's been happening lately and understand how those updates might affect your workflows. Whoops, sorry. And then this is really handy in the help section. There's available products. So if you're not sure, or you kind of know what you want and you know the general mission that's associated with the data you're interested in, you can kind of just zoom to these and say, oh, I know I want elevation data. What's available from SRTM? Okay, great. Well, Aster also has elevation data. They have the GDEM. What's available here? How do I find out more about this? Oh, this product is actually a global water bodies database. And then you can read all about that. So there's actually some really cool tools in here for you to explore and kind of understand the data products a little bit better. Whoops. Yeah. And so if you guys have any questions or problems, just go ahead and contact us. You can also post questions here. You can also email me directly. I know you guys are kind of working in a limited time frame. So we do, we try to get back to people within 3 business days, but it doesn't always happen. If there's something, you just need help with, feel free to shoot me an email and we can get you on the right track. Ooh, I hope that was AppEARS saying my thing has been processed. Yes. Okay. Because I know we're close to running out of time, but
this is so interesting and so valuable. I'm not going to be greedy and take the time back if you can use it. So.
Okay, yeah, let's just take a quick peek at what's happening here. I guess, so your request details are something that will be saved, like basically forever. Like this is a new account that I made with this new job, which I only started a year ago. But the account that I was using, like when I was doing my PhD, has every request I put in during my PhD, and that's insanely helpful. Sometimes you remember stuff, you forget stuff. Sometimes you kind of don't give enough information with your request ID, like how you've labeled it. And you can go back in and it will tell you exactly what you took and when it happened and what the spatial details of that request was. So that's really helpful. It's also really helpful for when if you end up publishing, it's what you're supposed to do is kind of say, you cite AppEARS, but then also cite the actual data. that you use in your research. And this will help you do that correctly. And also remember what version it was and when it was accessed and all that kind of thing.
I have a question for you, Bri.
Mhm.
Because everybody who's doing projects will be citing their data. Is there a format that you like to use when you cite your AppEARS data? And if so, could you show it to us?
Yeah. I mean, the format I like to use is I usually just use APA. Basically, whatever you choose is good. You just have to be consistent about it.
Mhm.
So, see if do I have a product page open? I'm sorry, there's so many citation. So this was the global water bodies product that we didn't know about and we were exploring. But say we did use that, we can just get a citation right there. And
Exactly.
all you have to do is say, oh, I'd like the APA. And then all you do is copy it right here. It's like easy peasy. You know, and it has all the information you need to be compliant with those APA guidelines or the Chicago guidelines. Say you want the Chicago, that's okay. Switches it. So there's a way to cite it from there. And I think they've recently implemented a citation tool in AppEARS as well, but I'm not sure if it's actually out yet. It's something that's on the docket for sure. Let me just change log, admin order. I'm not sure it's quite in yet, but that will be coming. The way to cite AppEARS. You can see I use Google a lot, even though everything's already open. Okay, is just to do the same thing. Go to the LPDAC website, and instead of launching AppEARS, you can do the citation. But this is the kind of the part that I was mentioning when you used AppEARS and what version it was is an important part of the citation. So kind of based on that information we were going through before, it's all there for you to see in the changelog and in your data request information and that kind of thing. And those basic components don't get deleted, but sometimes you do need to rerun a request. See, it says expired here, like when I was using HLS in 2022, like somewhere in the Midwest, I would have to actually rerun or resubmit that request using this orange button. And then you would be able to see all of that data again. Okay, so let's go ahead and I don't think I mentioned you can view the contents of the request here. There's also an option to download the request straight off, and you can also just toss it in the trash. But let's view the contents, see what happened. Okay, so we have multiple years. This is kind of why, like, sometimes I do like the point samples a little bit better for the exploration because it's a bit ahead of the area samples in terms of what you can see before you actually need to download things. Yeah, so this is our in-town sample, and I guess there's so many so many maps. Can I get rid of this? Well, anyway, my point is that there's a little bit less vegetation in town, which is what I was going to just say. Like, it's greener outside of town than it is inside of town. So what I would expect to see is that our in-town samples are maybe a little bit of a lower EVI compared to our out-of-town samples. So temporal comparison. Let's switch it to out of town and kind of just get an idea of what we're looking at there. You can kind of see when we switch it to out of town, it did go up a little bit. Well, those went down. So it would be good to kind of bring this data in and kind of interrogate a little bit more what's going on. But in general, at the same time periods, you're kind of seeing some of the out of town samples go up with the greenness.
Hey, Bri, one thing I want to kind of highlight here that always gets me, and I think is, sort of confusing right off the bat, is the dynamic range of the scale on the side. And so I just kind of want to highlight to everybody, don't get fooled, because it can make it, sometimes you can get fooled into thinking that there's a lot of variation without looking at the scale and the numbers on the side. And it's just reading in whatever those numbers are and doing a dynamic range. And so you notice that as you went from different site to different site, that scale changed. And so, I want to highlight to people, pay attention to those scale bars, because
that's a good point.
A lot.
0.7, 0.35. So let's.
What do those numbers mean, Bri? What's the actual range of values, right? Like that's where that metadata really
You're
helps.
absolutely right. Yeah. And so now when we go back in town, it's way lower. And basically I missed the awesomeness of my example because I was rushing. But if we were looking this on the same scale, it would be way higher out of town. And that's why it's super important to look at the values on the X and Y axis. Like totally. That's classic. Everyone at every age and every stage will sometimes make this mistake as a scientist. So
that's why I wanted to bring it up, Bri, because I've done that myself, and it's amazing how you will get fooled because of those dynamic ranges that make sense on one level, but in another, it would be nice when we have a standard vegetation index to have a standard range of values, because we know what those are, and so why just fool us into thinking that it's something else, right? Like and so I think that to me is another piece that I want to highlight to everybody, is pay attention to what the range of values are in the metadata, because there are some expected ranges with our values, and it's not just all digital numbers. There are some of these things that we kind of expect.
Yeah, and this, so I kind of popped down to a categorical overview. You can kind of see a summary of these numbers here, and now it is all on the same scale. So sometimes you just have to do a few more clicks, and the information you can see, okay, the average is 0.28 EVI. And up here in the out of town sites, the average is actually is over 0.5. So there really is some, I mean, maybe not significant differences, but noticeable differences. This isn't really enough to have a good sample size, but we can see that, as I kind of expected, it's greener outside of town than inside of town. And why is that? Well, because there's a ton of houses inside town, and outside of town, it's basically soybeans and corn. So yeah, they're green because they're growing. It used to be prairie, but now it's corn.
And I'll highlight here, everybody, our ideal here is that you would be able to load up all 36 of your sites and see them side by side. And you would actually be able to see possibly a variation. Again, I would say it goes back to the data that we're looking at. What is the original pixel size of that data? Because sometimes we'll only get one value for all 36 of them. But if we select the right data set, you might be able to see some variation even within your 3 kilometer by 3 kilometer area inside of there.
That's right. And like, depending on what you look at, 500 meters is really big. So maybe you guys want to use Landsat. Okay, Landsat's not all the way in AppEARS yet, but it will be. Will it be next week? I don't know. Maybe this week? No, next week it will be. Anyway, in the meantime, you could use something like HLS, which also has a 30-meter resolution. So there's kinds of options depending on what product you choose, and you're going to make that decision based on what you're trying to kind of pair with, like what kind of concepts are you trying to explore with the satellite data and match them to something in the field or different concepts about mosquitoes and different land cover types. So that's going to be up to you. Like 500 meters just might not be good enough. So maybe you have to drop down. There's also a product called EcoStress that is at 70 meters. That's a pretty good product, and it also has a lot of information about heat and evapotranspiration. So depending on what you'd want, you can get different things. We can also see that there's some disparities between, well, actually, this is just the near infrared reflectance, so that's not really a big deal. But we can see how the EVI kind of compares to the near infrared reflectance. And I could have actually chose NDVI, so we could be comparing two different vegetation indices, but we're not in this exact image. So this can also be a really useful tool to kind of see, just explore what's going on. Is the data looking the way I think it should? Do I need to narrow my time frame? Is there a year that's like really strange? Like what's going on in the summer of 2011, like between 2011 and 2012, like what's going on? 2011, sorry, it says it right here. What's going on that's different from what happened in 2008? You can kind of compare the different seasons. Well, 2007 looks like it had a really nice vegetation peak in the middle of July, early mid-July. And I don't think that's what we saw. Whoops. Let's go back. I don't think that's what we saw in 2011. No. See, in 2011, the greenness was peaking in late July. So, there's things that you can kind of think about and explore and kind of, just kind of casually test out with a little bit of data, if you'd like to, with these point samples, which is really helpful when you're thinking about your science and developing models.
Bri, this is wonderful. And this is, a great example of where where we want everybody to go with their own samples and their own data collection. And now, part of this, what you've been doing with the ground photos is trying to understand that big pixel that Bri was kind of showing. What is the variation on the ground, or what are the things on the ground within that 500 meters that are causing that greenness or causing that sort of change? So I love this, Bri. This is, really wonderful and exactly what we want people to be able to do. And so I guess, I want to take it back because I think there's a big question here that you've alluded to, which is, oh my gosh, out of all of this data, where do I start? What do I do? And you kind of hit on that with your graph at the beginning, right? And so I think, I would kind of ask the question of like, okay, what are some basic layers that people should start with and should just start exploring? And you kind of had some of those things listed out, but I think that would be a really useful thing so that, later people can go to their location and they can start gathering those pieces. And what Rusty and I will be doing is trying to gather that from everybody so that we can put it into one place and look across. And so you may not see much variation or interesting things happening in your 3-kilometer area, but when we actually start comparing it across all 50 of our research areas, that's where we might also start to see some differences in variation. So is there any recommendations in terms of data? You've kind of shown us 2, land cover and phenology, but are there any other ones that you would recommend us to explore?
In terms of the mosquito land cover?
I think in that same way, the termite piece of just, what are because the first thing is just like, how do I describe this location? Right? It really is that first piece of, before we know that this is an important variable, it's just, what are the numbers, right? Like what do we have here?
Yeah. So Yeah, I understand what you're saying. I think you guys might be able to reuse some of this, like these bottom three at regional. Maybe not the rainfall intensity, but how much rain occurs at a location, and like how long is the rainy season, or is there a rainy season at all? Like, what does that even look like? And sometimes, maybe you just get a physical number for the annual precipitation, and it's like 500 millimeters. Okay, well, that's kind of in the middle. 100 millimeters of rainfall a year is basically a desert. So that kind of helps you understand what to expect. But then, like, maybe I don't. So AppEEARS does have DayMet, which is, I don't know if you guys are working exclusively in the United States, or are you working globally?
Everything's in the United States right now.
Okay,
So that makes it a little easier.
Yeah, DayMet. Well, there's tons of the reason I ask is because I've always worked internationally, and I don't have the ability to use some of these data sets that that are like really high quality for the United States. So
And that is a
actually,
really important consideration. When we're selecting our data our data type, thinking about the extent and the coverage limits or facilitates our modeling. You can't go beyond that range of the data. So that is another important piece when we think about the data that we select. We want to think about, are we only going to be working here in South Dakota, or are we actually wanting to take it globally? And therefore we need data that it has that same extent.
Yeah, that's a really good point. You're like, you're nailing it, man. I really appreciate
Thank you, Bri.
your comments.
I'm here to help.
It is super important because it constrains what you can use. So, but if you're working in the United States, DayMet is available, and I think it started in the early 80s, and it has all this data for the whole country. So that's great, and you can learn more about it by going to the available products. Not sure if it includes Hawaii, but it looks like it's like North America, actually. I'm sure it says that. Oh, it does. North America, Hawaii, and Puerto Rico.
Cool.
Okay, good. So, like, if you guys want to get an understanding of, rainfall and different parameters that we knew were here because of the available products in AppEEARS, you can go ahead and do that. And that might be really helpful with.
That might be a great first step. Yeah.
Yeah, with the mosquito information. Then you go ahead and you combine the precipitation data, or kind of look at the precipitation data in conjunction with a measure of greenness, or how quickly an area greens up, or how long it stays really green and then dries out. That could be really interesting to see if there's any relationships there. I mean, you would really expect, especially in drier areas, for the vegetation plants to respond to having more water. They almost nearly always do. So you'll see that, but then what does that mean how does that relate to the time frame that mosquitoes breed, and like how does the temperature when that's happening relate to mosquito breeding success, like and things like that you might have more knowledge of, because like that's kind of the project you're working on. So like the remote sensing data gives you like a broad baseline of like understanding large scale things and sometimes small scale things, but then you get to add extra information and make it more meaningful based on what you're actually studying, and kind of try to tease out some relationships, like we see in this diagram. Like, can you understand if like the wet season, or it rains for a longer period of time, like do you think there's going to be more, or does the data indicate in any way that there'll be more or less mosquitoes and more or less cases of mosquito-borne illnesses and that kind of thing? So it's kind of fun. It's a little overwhelming But it's also fun because you get to be the detective and you get to kind of think about solving problems in any direction that you think might work.
Mhm.
So
And the
I think
first thing is just
yeah.
gathering the data to describe that location before you start making assessments, right, Bri? I mean,
Well,
that's
that's
the
true.
big thing. You know, do you have any south-facing slopes to begin with? You know, or is it all flat? You know, just gathering that information is kind of this next step that we're hoping people will spend the next week doing, is gathering these different attributes to describe their area of interest. And then, you know, you've done a great job of highlighting how you interpret some of those things, and then really how that leads to the next question. Well, why is that? What's going on there? How is there a year that's out of sync with other years? And,
Yeah.
you know, and might that mean that there's less mosquitoes in that year if we went to another database that was recording that? Right. And so I really appreciated you walking this through. Even with a termite example, it's the same thing. It's an organism that's responding
Yeah.
to the world around it.
Yeah. And
That's
so I just wanted to share with you guys quickly, like a very quick trick that I sometimes use. Like, the satellite data is great. Like, I love it. It's very consistent. It's spectrally, I mean, for the most part, spectrally very high quality. But sometimes you can get like even just a good idea of what's going on from Google Earth and kind of just zooming in. I like to use this historical imagery button, and you can go back through time and sometimes see different. So this is, let's see, 11/20. This is November. The next one is 10. What is that?
October.
October.
But it's almost a year later, isn't it? Like,
It's a year later. It's a year later, but this October is extremely green. You know, it looks lush. But then that November was looking pretty dry. It doesn't look that lush at all. So like sometimes you can get an idea of you know, what's going on by kind of just looking in Google Earth Engine. 13 west, 15 north. I will just quickly show you that I have spent so many hours of my life looking at termite mounds on Google Earth trying to figure out what's going on. You know, and so you could see the contrast
Oh
of
my
these
gosh.
termite mounds
Oh
in
my gosh.
November.
Yeah.
It's high, right? And then, oops, let's see, if we zoom out a little, and you can kind of see the scenes change. Okay, so, you know, because this is all like an amalgamation of different data sets. But now when you zoom out, sometimes you have access to different scenes, so a longer temporal range to kind of interpret what you're seeing. So let's go in here. This looks interesting. You know, more termite mounds, great. Oops, we lost another scene, that's okay. But let's see what it looked like before. Okay, that's not as good quality, but it does look less green. You know, so it's not always perfect information, but sometimes a lot of the game is just understanding what you're seeing and kind of
Exactly.
understanding the system you're working in so that you can interpret what you're seeing in the data even better.
This is fantastic. Bri, would you be willing? I think we're close to the end of our hour, but I would love to have people ask any questions they might have after this brilliant discussion. And, you know, I think that we'll have some other comments after the break. But first of all, I just want to thank you right now for this incredible exploration of the AppEARS data, and also you sharing your insights on how to look at your data, how to explore data, how to think about data. And also the very first slide you showed where you talked about how, you know, the people are kind of unhappy all by themselves, and then they come together and they work as a team. And that's, you know, you gave plenty of examples why, you know, each of us are working in our own area of interest where we're located, but all our data comes together in our team. And from that, the kind of analyses that we can do as a group is really kind of unlimited. And so if everybody takes the time to enrich their own AOI with these other data sets, this will give us an opportunity to do some really exciting explorations.
Yeah,
And
that's
that in
awesome.
itself, that kind of when you describe the environmental data for your AOI, this is already original data, original research no one has done before. You know, that in itself could be a project, right?
Oh yeah. I mean,
know,
some of this
it's
just
incredible. Yeah.
it's you always need a baseline, and sometimes the baseline isn't put together the way you need it. So the only thing to do is to make it. And then, so that's what you guys are doing. You have some questions, you have a team of people. You're going to all do something, then you'll pool your resources and and then see how what you've done individually kind of comes together and provides new insights that you might not have been able to get just with 2 or 3 sites. You get insights that are much broader, and like you can connect new dots, like maybe scientifically, that you weren't really able to do before.
Great. Are there 1 or 2 questions for Bri before we let her go? She's been very generous with her time today. You may have been so comprehensive, people don't have any questions. I don't know.
That's totally fine. They did a great job last week on the questions. You guys nailed it.
They did. And so I'm really hoping that we'll be able to contact you again, Bri, and bring you back in to meet with this group in the future. And
I'd love to see what you guys are up to and how it's going.
Yeah, you know, if you are really interested, we will be presenting our projects in the end of July, and there'll be 3 days of presentations, and I'll let you know when they are. And if you're able to drop in, it's all done through I think they do it through YouTube. So
Okay.
I'll let you know about that, and we'd love to see
Sounds
you
good.
there. So let's give Bri a virtual clap here, handshake. And thank you so much from the bottom of our hearts for being part of our NASA network. We really appreciate it.
No problem. Anytime. See you guys later.
Thank you. Bye.
Bye.